Welcome to the discussion of distillation, the macro scale technique that we're going to use. So what you're going to be doing is taking your banana oil that you created. Now with the reaction that we did, you should have probably, what we're going to look for is three different chemicals. We're going to look for your all three of your original starting materials. And then we're going to also be looking for the product as well. Now when we work this thing through, if you'll remember, we thought that our limiting reactant would be, for the most part, would be the amount of we had two things in there, the acetic acid and the alcohol. But even though we know it's an equilibrium reaction, we know that probably we tried to make the alcohol be the limiting reactant. But we're going to see that probably there's going to be some of it because of equilibrium that was not used. Now the acids were both destroyed when we washed with baking soda. That would have neutralized them and turned them into salts. So therefore, we really shouldn't see any type of a peak. And I'll talk about that when I talk about the gas chromatography. So for distillation purposes, let's just look at that. We're going to be looking at the distillation. Obviously is just we separate things based upon the differences in their boiling point. So the boiling point, remember, is when the temperature, which is the vapor pressure of a liquid, equals the external pressure. And the vapor pressure depends on what the substance is and what the temperature is. Typically, as temperature goes up, vapor pressure goes up as well. So Raoult's law says that for a mixture, and you're not going to have to do any math with this, we're just going to really look at the theory of it. If you have a compound 1 and 2, the total pressure of the solution is equal to the mole fraction of each compound multiplied by their vapor pressure. So you can see that if we, for an example, if you have a mixture here of toluene and cyclohexane, you can see that on this curve at any particular temperature, we can see that the percentage of one of the chemicals is going to be in there is going to be different than the percentage of the other chemical. So the higher the vapor pressure, the more the boiling points you'll see on this. Here's a lower boiling point, a higher boiling point. You can see on these curves of the cyclohexane boiling point is here, and the toluene boiling point is here. That in between those two boiling points then, between the lower and the higher, we're going to end up with a boiling point that's going to be somewhere in between in the mixture. And the percentage of what's in there is going to be different based upon what the temperature is. So you'll see that there is, at this point, there is a difference here of, it's about, maybe 70% at this temperature, 70% toluene, or excuse me, cyclohexane, and it's going to be about 30% toluene. Cyclohexane has the lower boiling point, so you can see at this point here is its boiling point. So at that point we're going to have about a 70-30 mix. The vapor pressure here is higher, so this doesn't boil until a higher temperature on that. So you can see how those two differ as we move up the line. So typically what you want are two things that their boiling points are 40 degrees apart. You'll have to look at the boiling points in ours. It really turns out that for our alcohol and for our ester that we made, that is pretty much true in this case. So you can see the process we're going to use is just a one vaporization step, and we'll talk about a more extensive one later. So fractional is what we'll talk about later. I would come back and talk about this later, but the idea would be here would be you would do multiple evaporations and condensations to change the richness of the material at any given temperature. But we're not going to discuss those differences tonight. So in a simple distillation system, you'll see in a fractional distillation system, your percentages or your volumes of distillate, you'll notice, stay pretty flat at one of the boiling points because we are doing the condensing and boiling and recondensing and boiling, that our mixtures stay better for a longer volume. In other words, the flatter this is, that's the most important part we want to see. The flatter this line is, that means that we're keeping the boiling point at the same temperature and we're collecting more distillate. It is more pure. Here you can see the mixture is changing at almost every temperature when we do the simple distillation. So what we'll do is analyze at our boiling point when we collect it. We'll collect some different portions, and then we'll analyze those portions to see what's in them. Fractional distillation, much more efficient, more costly, much slower. But if you got things that are closer together in boiling point, it's a must to use them. The simple distillation is all you need to worry about. I put a video up, the video up about distillation, so you can see how to set up your system and to clamp everything together. If we have any lab jacks, you can put them here. You'll probably have to find whatever you can. Sometimes it's books, sometimes it's just blocks of wood, other test tube racks or something to put under here. You're going to use your heating mantle in here, 2 boiling chips. You put the distillation head on it. You put your thermometer through the thermometer adapter, that's that rubber adapter, and you bring it down until you'll notice we drew an artificial line right here. I've got the bulb of the thermometer on that artificial line. And then your cold water is going to come in the bottom and then go out the top of this. You'll have your adapter on the condenser and then something to catch it in. We'll come back and talk about fractional next time. Now there's some things I've changed in your packet that I did not change here, and I apologize for not updating this. It says mixture of water and ethanol here. That's not what you're going to do. You're not going to do water and ethanol. You're going to do your mixture. 2 boiling checks. Have me check it before you get going. A good distillation is going to occur when you're obtaining about 1 drop coming out of your receiver about every 2 to 3 seconds. If it's coming out faster than that, you need to slow down your heating rate. If it's not coming out that fast when you start making product, you need to heat it up a little extra. And then it says record the temperature every time you catch 2 milliliters of the distillate. So as the distillate is piling up, you're seeing if the temperature is changing. Now don't worry about this part. Don't read these last parts because we're not doing the fractionating at this point. So you don't have to go beyond that with the glass beads. That would be the next time. So that's really all you have to do. Watch the setup for the video, and then the major portion of it's going to be the analysis in the gas chromatograph that we're going to make of what you have. So that's all we'll talk about on this one, and we'll go to the second video where I talk about that.